All right, guys, this is going to be our last problem for the trees node, or the tree series for the easy trees. Go ahead and try to solve the last one. Okay, it's called subtree of another tree. This is really similar to same tree, I'm thinking, but let's go ahead and try to solve it, see if we got this. So we're given the root of two binary trees, root and subroot. Return true if there is a subtree of roots with the same structure and nodes values of subroot. Otherwise, we return false. See, so we can see that subroot is 2, 4, and 5, and this is right here on root, and it's a subroot of root. See that this is 2, 4, 5, 2, 4, 5. I would say that is false because the root of root, or the outline of root has a 6 in it. Subroot does not have that. Some pretty good hints, or not hints, some pretty good examples. Let's go and check it out now. So we're given root and subroot. We could safely say that if not root and not subroot, then we could just return true. If there is a root, if there's not, so that's if there's not both. If there's not a single one, it's not a root. If not subroot, we could also return true. And if not root, return false. Because this is assuming that we do have a subroot, right? Yes. Very good. Now, let's go ahead and define a def for search. I think we're gonna use self here. Let's define a def for search and check. So we keep on checking subroot. We go down the root tree and stay stationary. Let's just say static. Sounds cooler. On subroot. Okay, so we could just kind of check. We give it a root and subroot. Alright, go ahead, check it. I think we do the same checks as this before. I think we just put this in here actually. Oh, if we do it like that, we don't even need the self anymore. Let's see how to comment out. I guess I'll just do it like this. Oh shit. Does this work? Okay, there you go. We just call it again, we recurse if, I think we call it on root. We return root dot left. I think we compare a lot of stuff actually. We should compare if root dot value is equal to root dot sub root dot value. And root dot left. Check the left subtrees, so that would be differ search root dot left. Subroot. Okay, that's one of them. And we gotta check the right one too. Differ search of root dot right. Okay, check if the current root is good. If the left tree matches. And if the right tree matches. Subroot val. So if this is true and this is true, so this would be false. So root and subroot are these two. So root.val and subroot.val, these are false. So what should we do? We should increment subroot. It's not equal. If it's not equal to subroot.val, then you go ahead and do the search. When it is equal. So, okay, so these are not equal. So, if root.val is not equal to subroot.val, defer search on the root node. Okay, root left, so that'd be this. And subroot, so that'd be that. And defer search on the right. So that would return false. But this would be true. I don't think we use and here. We do both of these. We could use or actually. Okay, now let's go down this case, right? So 2 is matching with 2, so it is equal. Oh, if not self. I think this would actually work. This might be a bit recursive, so I would put this maybe outside the function. We only have to check this once. I think this could work. Oh, I see. Sometimes this will return true or false. This one will return false parameters. And we just call it. Do we return that? If we call this, it'll return true or false. Okay. Like something's wrong here, but I'm gonna try search it. Oh, this comment not work? Expected indentation. I'll take this out. Yeah, we don't need to use self right now. I think we do need self for these though, right? Solution has no attribute root. Because you don't even need self. Balls. If not root and not subroot, return true. Because I'll call in some help. I think we only have to check this once though. I think something right here. Oh, actually, you gotta do if equal. Oh, this. If they're all equal, then you just I say call it again. Maybe we just keep on calling it regardless. Yeah, I was thinking the same thing. If there's not a root and there's not a subroot, we return true. If there's not a subroot, return true. If there's not a root, return false. If they're equal to each other, we should call the function again, except on the left subtree. Ah, I get it. Try it again, but we should just return. We should return def first search on the root dot left subtree and subroot dot left subtree. Right? Because they're equal. And def first search the root dot right subtree, and we gotta check out with the right one too. Subroot dot right. Yeah, these have to be. Yeah. This is it. Oh, it's not. Okay. All right. There's not a subroot. see if this worked. I don't know. We'll see. All right, I think this question's stopping me. I might have to restart it. All right, let's see. Okay, so first we do define the first search. We give it a root and a subroot. Check if not subroot. True. If not root and subroot, turn false. Okay. Let's see if there's a root and not a subroot. Okay. If not and not subroot, return true. If root and not subroot, return true. All right, now we just check if is equal to subroot dot value. Then we go ahead and run this algorithm. We return root differ search on root left subroot dot right and dot, so both be left. Check if they're equal. Okay. And if they're not, then we should just return their first search. Just keep on searching the subtree, the main root. Subroot dot left. Compare with the subroot. Or differ search on root dot right subroot. Okay, now we just call itself again. Say we call the function now, which is differ search. We put in our root, put in our subroot, right? And then this will return a Boolean, so we just return true or false. Okay, we could run down our algorithm. Let's see, we have 1. So if root and not subroot, there's a root and there is a subroot as well. So we'll skip that. If there is a root and a subroot, if there's not a root, well, there is. And if there's not a root and not a subroot, return true. Okay, so it's neither of those. See, is root.val equal to root.val? No, it's not. So we return root.left and subroot. Okay. And now we see that they are equal. So we return their first search on root.left and subroot.left. Okay, so we check them. So they are equal. And so we return it again. And that means that they're both not there. So we just return true for that. And we do the same for, I think this should be a good solution. Let's go check it out. And we run into a problem. Okay. I outputted true when it should have been false. So root is 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. Okay, so it didn't work for this one. Let's try to walk through it. So we have this. It's not equal, so we turn the left one. Okay, so this is equal. Okay, so I think the problem comes right here. So these are equal. So we have a subroot. Subroot has ended, but root has not. I see. Okay, so we hit 4. We have a root and not a subroot. We shouldn't check for this case. This is only for the base case. It only happens for the first one. Then type. If root.val is equals to subroot.value. If there is a root and not subroot, return false. Yeah, this should work. No? Hmm. Damn, this one's stumping me. Compare two trees for equality. Search down the big tree for a match. Okay, so we have 3. Okay. Suggesting that we should split our function into two. Okay, how do we check if it's the same tree? Well, if not root, well, we could assume that we do have something ready, right? So, if not root, otherwise we call depth for search. If root to sub, uh, just return. We call it on the same thing, okay? On right, if it's not, just keep on going down. Is same true root dot right? And we just check it with the subroot. We check it with the right side, and then now we check it with the left. Right, we just keep on going. Right, we'll just keep on going to one of these say true. This is, I feel like this is too deep. Could say return, because they're equal, right? Same true, right? It's not on the left. False. Does a tree have unique nodes? Let me look at the constraints. This could work. But this has right? I think that's the weakness. Yeah. Okay, so if there's not self dot root and not self dot root. Mm. If self dot root, if there is a root and not a subroot. Okay, so if there's not a root and if there's okay. Hmm. Otherwise, I think we just return it, right? We just return is same tree. We put in root and self dot roots, and we put in self dot. Why not self? Comparison's too deep. Okay. Okay, and if they are equal to each other, what do we want to do? We want to call the same function on the left and the right. Call on the left. The recursive method, right? Okay. Now we should check. We didn't really call this function yet. Let's go check if there's a root and not a subroot. We just return true, right? And if there's not a root and there is, then just return false. And then another case would be if there is a root and there is a subroot. Okay, and then we could just say, now we say if root dot value is equal to subroot dot value. And what can we do? Then we just call it the same tree. On the root dot left and on the subroot. They have to be the same on both left and right. Okay, and if they're not equal, We call the same thing. It is same tree. I'll say if root value is not equal to the sum of root value. I want to just say like return say, tree. Do that on like the root dot left. Compare it to subroot or right. We're like splitting it up too much. So this is calling itself recursive. If there is a root, if root and subtree, and then call this. You gotta call itself. Subtree. It's gonna run forever, bro. Damn, solution all over the place. Yeah. Okay, let's fix this. If there is a value in A but not a value in B. The same true root that is false. Course me. Okay, now we're a part of this. Root is optional. Okay, now we check. Turn true. There's no subroot. Turn true if there's no root. You assume that there is a subroot. Okay. And then for all other cases, if root value is equal to value, then run the def. Just return is same tree on left on root dot left on root and subroot, but they're not the same. Root dot value is not equal to sub dot value. Then we'll just we'll skip it. We're gonna go past. You could say turn is same. Oh man. Same tree on root. Yes. Subtree. If not subroot, return true. If not root, return false. If is same true. All right, bring it back. What's up? Yeah, it's pretty good. Makes you look neat. Makes you look more neat and sophisticated. Yeah, I think it fits you, yeah. Why not? You think it's a bit tight? Yeah, I feel like it fits, it looks fitted.
As a person,
You
like
as a
like
person? Uh, Probably not. But you could be like that though. You could be sophisticated. Nah, man. It just makes it look like you care about style. Caring about style and being gay is different.
same thing.
No,
Yeah.
gay is like if you didn't even put on a shirt below that.
What?
Wait, hold on. No, don't say nothing crazy, bro. I'm recording this shit. I'm in the middle of a lesson. But like, if you took off your shirt, bro, and you just put on that blouse without a shirt, and you just show skin, then that's gay.
You can't say that shit.
Yeah, I don't give a fuck, bro. It's my private channel. I'm posting this, by the way.
Like, I feel like it doesn't fit my vibe, which doesn't matter to me, right? But it's like imagine it's like if I see you wearing this, I'm like, what? You know?
Is that it?
Yeah. I mean, okay, it fits though, right? Like, it looks good,
Yeah,
right?
yeah, looks good.
That's it.
See, if it's the same tree, then return true, right? Mm. If true, then return true. If false, just skip it. Wow, that's actually pretty good. I never thought of using this like that. Okay, if it's not a subroot, then we return true. If there's not a root, I think this is true though. Okay, now what do we do? I think we call we want to just kind of go to the left subtree, right? This case, we want to go to the left. We want to compare sub roots with the left and right sub of root. How can we do this? We call it is same tree on. Oh yeah, we call this on the left. Left. Compare it with subroot. If one of these return true, that's good. All right. Oof. Oh, come on, is this it? No, okay, fuck. Maybe it is, right? Because I'm thinking if it's not a subroot, right, then we could just say, because we compare nothing with something, right? For example, we'll go back to this picture. If it's not a subroot, if this is zero, zero is always inside something, right? Because zero is everywhere. And if it's not root, that means they're both zero. They're both zero, wouldn't that return true? Well, we're calling this recursively, right? So we want to just make this false. I think there's that one base case, like just the first iteration that we do. Let me see. Missing a couple of cases. When we are searching down a big tree, are we trying to compare two trees directly? Or keep searching for a possible starting point? No, we're trying to find a new starting point all the time, right? Yeah, I meant to call this one. It's there here. Self is subtree. Okay. Well, we solved it. I think that took about 40 minutes. Let's go ahead and end the video now.